Okay, so this is our first video in the Recursion and Financial Modelling unit. And we want to start off not by talking about any financial applications just yet, but by looking at sequences of numbers and how we can describe sequences of numbers. So a sequence is a list of numbers written in order, and each of the numbers in the sequence is called a term of the sequence. The terms of a sequence are written as a list separated by commas, and if the sequence continues indefinitely, then we can indicate that by using an ellipsis, which is the three dots. So for example, a sequence could be written as 1, 3, 5, 7, 9, 11, comma, dot, 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 suggesting it continues on indefinitely, and we can see we have enough of the sequence listed there to be able to see the pattern to establish how it continues. So we're really only looking at sequences where we have a clear pattern, and when we have a clear pattern we can define the sequence by a rule. And the rule can be fully described by giving the starting value and then the recursive pattern. Okay, so where do I start and what do I do to get to the next term? That's essentially what we would need to know to be able to generate this. So in this case, the sequence starts at 1 and each successive term is found by adding 2 to the previous term. Okay, so write down the first 5 terms in each of the following sequences. So if the starting value is 13 and the rule is subtract 4, the first term would be 13, the next term would be 13 minus 4, which is 9, the next term would be 9 minus 4, which is 5, the next term would be 5 minus 4, which is 1, we want the first 5 terms, so 1 more, and the next term would be 1 minus 4, which is negative 3. And then we can indicate that the sequence is continuing. In part B, the starting value of the sequence is 1, and the rule is that we should multiply by 3 to get from one term to the next. Okay, so that means the first term of our sequence is 1, the next term of our sequence is 1 times 3, which is 3, the next term is 3 times 3, which is 9, the next term is 9 times 3, which is 27, and the next term is 27 times 3, which is 81, and it can continue. And in part C, we want to write down the first 5 terms of a sequence which starts at 6, and the rule is to multiply by 0.5, which means halve, and add 5. Okay, so we're starting with 6, we're going to halve it, multiply it by 0.5, which is halving it, which gives us 3, and then add 5 to it, which gives us 8. To get the next term, we're going to halve 8, which is 4, and add 5, which is 9. To get the next term, we're going to halve 9, which is 4.5, and add 5, which is going to give us 9.5. And the final sequence, we're going to halve 9.5, which gives us 4.75, and then we add 5, so we get 9.75. Now obviously you can use your calculator to help you calculate each of those terms if need be. So when we're generating a sequence with our CAS, you can use a spreadsheet. I'm not going to talk about using a spreadsheet. If you're comfortable with spreadsheets, that's a way you can do it. But to be honest, the easiest way is to just be careful about how you set up the sequencing in your calculator. So if, for example, I wanted to generate that first sequence that we talked about in part A, starting value of 13, and the rule is to subtract 4. What you want to do, so there's a few steps early on which just talk about setting up a calculator page. I've already got a calculator page set up. What I need to do is, the key thing is to make sure that the first thing you do is type in the starting value and press enter. Okay, and then I want to subtract 4 from that. So I don't type 13 minus 4. The first thing I press is the subtraction button. So not the negative button, which is next to the enter, but the subtraction button, which is above the enter. So subtract, and see how it says ANS? That's it understanding that I want to subtract from the previous answer. So subtract 4, enter. Now all I need to do to repeat that is to press enter again, and enter will do the previous calculation, which wasn't 13 minus 4, it was to take the previous answer and subtract 4. So if I just press enter, it'll do 9 minus 4, enter again. So now we're up to the 4th term in the sequence, 5th term, 6th, 7th, 8th, 9th, 10th. And it's very quick and easy to then generate your sequence. So for example, part B, that sequence, we start at 1, so we press 1 and press enter, okay, and then we multiply by 3, so I don't type the previous answer out, the first thing you press is the operation, so multiply, and it automatically brings up answer. It understands that if the first thing you type is an operation, that you want to do that operation to your last answer. So we want to multiply by 3, so we get our second term, third, fourth, fifth, etc. Final part C, starting value is 6, so type 6 and press enter, lock in that starting value, okay? And then we want to multiply by 0.5 and add 5. So again, the first thing I want to type is an operation, so multiply by 0.5 and then add 5. So that's done 6 times 0.5 plus 5, which is 8, which is what we got. And then if I press enter again, it'll again take my previous answer, multiply it by 0.5 and then add 5 to it. 9. 9.5, 9.75, etc. Oh, sorry, I wrote 9.74. I think I said 75 when I did it. And we can continue. Okay, so that's how you're going to generate your sequences with your CAS really easily. Right, now we need to introduce some notation, and a number of students find this notation quite complicated, but it's really important that you get on top of it. Okay, so let's say we have a sequence which we're going to call P. Okay, it can be called any letter. We usually use a capital letter. So in this first paragraph here, I'm going to be talking about a sequence which I'm going to call P. Then we would refer to the specific terms in sequence P using subscripts. Okay, so usually we would refer to the starting value as P0. That's the starting point. And then the next term that comes after that would be P1. And the next term that comes after that would be P2. The second term in sequence P. The next term after that would be P3, the third term in sequence P. Now be careful sometimes you need to be a bit careful about P0. If we're talking about P0 being the first term, then actually P3 is the fourth term. So sometimes just be a bit careful about the notation, but that's going to be specific to your applications. Don't get too bogged down in formulas and rules here, or you'll get yourself confused. Okay, so it's a subscript. It's not a superscript. We don't write P to the power of 0. That's not what this means. It is just the 0th term in sequence P, the first term in sequence P, the second term in sequence P. Okay, we're not squaring it or cubing it or whatever it might be. So a subscript, not a superscript, which is what a power is. Okay, so if the sequence P is the one we talked about at the beginning, so 1, 3, 5, 7, 9, etc., then P0 would be 1, and P1 would be 3, and P2 would be 5, and P3 would be 7, and P4 would be 9, etc. Okay. So that would be how we would talk about the sequence. I might leave that written there. I'll come back to it. So, for example, if we had another, and then if we had another sequence here. So, so let's talk a bit more generally about the sequence. So, we can now say, so we understand that P2 is the second term in sequence P. P4 is the fourth term in sequence P. So if we want to talk about a sequence really generally, so let's have another sequence that's called R. So we're going to have R0 would be the starting term of that sequence. R1 would then be the first term after that. R2, R3, etc. And we can talk really generally about a term, Rn, which would be the nth term in the sequence. Okay, R5 would be the 5th term, R7 would be the 7th term, R25 would be the 25th term. Rn is the nth term in the sequence. Okay, so that means, in fact, I'm just going to leave us a bit more space here. Rn is the nth term in the sequence. So that means the term that comes after that is Rn plus 1. So if this is the 6th term, this is the 6 plus 1th term, the 7th term. If this is the 21st term, this is the 21 plus 1, 22nd term. Okay, so it's a general way of talking about the term that comes after the nth term. Similarly, if we want to talk about the term that comes before the nth term, that would be Rn minus 1. So if this was 6, then this term is the 5th term, 6 minus 1. If this is, 25, then this term is 25 minus 1, the 24th term, R24. Okay, so we've got this general way of talking about 3 sequential terms in the sequence. Okay, so we could have, and we could keep going, obviously the term that comes after the n plus 1th term would be the n plus 2th term, etc. Okay, so we can talk generally about the terms. And that's really important when we come to our talking about our recurrence relations. So, for example, I'm going to come to the example down here. Actually, it's the same one, so we'll go into it now. So, a recurrence relation is when we formalize our description of a sequence by using the above notation. So, for example, let's go back to this original sequence 1, 3, 5, 7, 9, 11, etc., which we referred to as P in the previous paragraph, and here I'm referring to it as V. This would be how we would describe this sequence using what we call a recurrence relation. So it's still the same information that we were given in words earlier. We need the starting value, which is V0, okay, the initial value of the sequence. And we also need to know, how do we recur the sequence? How do we get from one term to the next term? Okay, so you'll remember, let me just write this out here. So much like the sequence involving R up above, a sequence V is going to start with V0, and then there'll be V1, and then there'll be V2, etc. And then we can talk really generally about the nth term, Vn. Okay? And the term that comes after Vn will be Vn plus 1. So we know in this sequence that the way we get from each term to the next is to add 2. So that means to get from Vn to Vn plus 1, we're going to be adding 2. Okay? So what we learn from this is that the nth plus 1 term of the sequence is equal to the previous term, the nth term, plus 2. Okay? So all you're looking at here with this notation is that this is a term in the sequence, and this is the term that comes before that in the sequence. It would actually be correct to also talk about the nth term in the sequence is the n minus 1th term plus 2. Again, this is a term in the sequence, and this is a way to describe the term that comes before that. Okay? Both of these things say the same. So again, don't get too bogged down in notation. It's about the connection between this and this. This is the term before. Okay? Same here. If you go from n plus 1 to n, you're just going to the previous term. Okay? Right, so we've got this recurrence relation. So it tells us that V0 is 1, you start the sequence at 1, and then to get to a term, you take the term before that and you add on 2. Or you can think about it as, you take a term, you add 2 to it, that gets you to the next term. Okay? So it's about being able to understand the notation and also being able to formulate the notation. So as it says here, you can use any capital letter as the name of your recurrence relation. In an exam, it will quite often in the questions specify which letter you should use, and it's really important that you use letters that are consistent with the question. So we get used to, in the example, often using the letter V. Be careful about just defaulting to V every time. If the question in the exam specifies that the sequence is called P or C, then you must be talking about PN, P0, etc. Okay. So the reason we commonly use V is because we're going to look at this in the context of financial applications, and we often use V because we're referring to the value of the investment or the value of the loan. Okay, so we want to now describe each of the following sequences, which are the same ones we wrote out in example 1, using a recurrence relation. Okay, now it's also conventional, certainly VCAR seemed to like, and there was a comment in an examiner's report some years ago, that you give the starting value first and then you describe the recurrence. And that's naturally how the sequence would evolve. You need to know where to start, and then you need to know how to get to the next point. Okay, so we're going to try and create that habit as well. All right, let's use the letters of the questions as our sequence. I'm going to call this sequence A. So A0, the starting value is 13. Now, to get to AN plus 1, which is the next term, we take the current term, which is AN, and we subtract 4 from it. Okay, so we take a term and we subtract 4 from it, and that gives us the next term. Or to get a term, we take the previous term and subtract 4 from that. Okay, so just really try and think about that this is the next term, or this is the previous term. That's all we want to understand it as. Okay, it doesn't really matter. You know, technically it would also be true if we talked about, you know, AN plus 7 is equal to AN plus 6 minus 4. oops, mine's 4, sorry. This is the term that comes before this one. Okay, so it doesn't really matter precisely, but we tend to use n and n plus 1. As I said though, another way you might see it is to see an is equal to an minus 1 minus 4. So this being the term that comes before this one. Okay, part B. So let's call our sequence B. So B naught, our starting value is 1. To get to Bn plus 1, which is the next term, we take the current term, which is, Bn, and we multiply it by 3. We would conventionally write that rather than we don't usually write x times 3, a variable times 3. We usually write that as 3x. So we would probably write this as 3 times Bn. But it wouldn't be wrong to write it as Bn times 3. Okay, and then the starting value of 6 in part C. So C naught is going to be 6. And then Cn plus 1 is, so we take the previous term, we multiply that by 0.5, and then we add 5 to it. So once again, we would probably choose to write that as 0.5 times Cn, but it is technically the same thing. Okay, so there's our 3 recurrence relations. Let's work the other way. So let's now, given the recurrence relations, see if we can understand it and generate the sequence. So here in part A, we want to write down the first 5 terms. So here in part A naught is 5. So the first term in the sequence is 5. And then we look at the recurrence relation, the recurrence section of the recurrence relation to tell us how do we get from one term to the next. So to get from one term to the next term, okay, it's clear that we're going to add 3. So to get from an, we add 3, and that gets us to an plus 1, which is the next term. So we're adding 3 each time. So this is going to be 5 plus 3 is 8, plus 3 is... So essentially what you're looking at here, what I did specifically there to get 8, is we're trying to find A1, and we know that's going to be A naught plus 3. Okay, and A naught was 5. Okay, at the next step, we're going to be trying to find A2, and we know that is A1 plus 3, and A1 is 8. 8 plus 3 will mean that it's 11. Okay, then we want to find A3, which is A2 plus 3. A2 is 11. 11 plus 3 is 14. Okay, so that's how the recurrence relation is working. So we're adding 3 each time. And obviously it would continue on beyond that, but we're just asked to write the first 5 terms. Okay, in part B, this time B naught is 100. So the starting value is 100. And this is what we're doing at each stage. So to get from one term, we're multiplying by 0.5 to get to the next term. So we're halving each time. So multiplying by 0.5, or half of 100 is 50. Half of 50 is 25. Half of 25 is 12.5. And half of 12.5 is 6.25. That's the first 5 terms in that sequence. Okay, part C. The first term in the sequence is a 3. And then here's the rule that tells us what to do to it. So this is our current term. We multiply by 2, then we subtract 7 in order to get to the next term. So we're going to double and add 7. So 3, we double that, we get 6. Sorry, not add 7, subtract 7. 3, we double 3, we get 6, and we subtract 7, we get negative 1. Double negative 1 gives us negative 2, subtract 7 gives us negative 9. You can use your CAS, and in fact, once you've understood the sequence, you can use your recurrence relation. So let's practice that here again. So if I type in 3 and press enter, which is the starting value, I then need to multiply by 2 and subtract 7 to get the next term, which is negative 1, which is what I found. Enter again. We'll do the same calculation. It'll take the previous answer, multiply it by 2 and subtract 7. It's negative 9. That's what I found. The next one will be negative 25, and the next one will be negative 57. And you could have done the same process with the previous ones. So the starting value in part A was 5. At each step, we're adding 3. So our second term is 8, 11, 14, 17. Okay. In part B, your starting value is 100. At each stage, you're going to multiply by 0.5, 50, 25, 12.5, 6.25. Okay, so the work today is from exercise 8A and 8B, just becoming familiar with this notation around recurrence relations, being able to both interpret it to work out what the sequence is, and also being able to describe a sequence using a recurrence relation.